Good morning, students. Today we are going to see about IoT network architecture and design. I am Dr.R.Suganya, Department of Computer Science with Cybersecurity. Comparison of comparing IoT architecture. So, in past several years, architectural standards and frameworks have emerged to address the challenge of designing massive scale of IoT networks. The foundational concepts in all these architectures is supporting data process and the functions that endpoint devices perform. Two of the best known architectures are those supported by one M2M and IoT World Forum. The one M2M IoT standardized architecture. The European Telecommunications Standard Institute created the M2M Technical Committee in 2008. The goal of this committee was to create a common architecture that would help accelerate the adoption of M2M applications and devices. The goal of one M2M is to create a common services layer which can be readily embedded in the field devices to allow communications with application server. One M2M's framework focuses on IoT services, applications, and platforms. These include smart metering applications, smart grid, smart city automation, health, and connected vehicles. One of these greatest challenges in designing an IoT architecture is dealing with heterogeneity of devices, software, and access methods. By developing a horizontal platform architecture, one M2M is developing a standards that allow interoperability at all levels of IoT. The one M2M architecture divides IoT functions into three major domains: the application layer, the service layer, and the layer. So, here we have the diagram: automation applications, home application, and energy applications. We have application layer, that is smart energy, asset tracking, fleet management. In service layer, we have one M2M includes a common service horizontal framework supporting the RESTful APIs. And in network layer, applications talk to APIs to communicate to sensors. Applications layer. The one M2M architecture gives major attentions to connectivity between devices and their applications. This domain includes application layer protocols and attempts to standardize northbound API definitions for interaction with business intelligence systems. So, applications tend to be industry specific and have their own sets of data models, and thus they are shown as vertical entities. Services layer. This layer is shown as horizontal framework across a vertical industry application. At this layer, horizontal modules includes physical network that the IoT applications run on, underlying management protocols, and the hardware. A critical objective of one M2M is to attract and actively involve organizations from M2M related business domains, including telematics and intelligent transportation, healthcare, utility, and industrial automations, and smart home applications. Network layer. This is a communication domains for IoT devices and endpoints. It includes the devices themselves and communication network that links them. Embodiments of this communication infrastructures include wireless mesh technologies such as IEEE 802.15.4 and wireless point to multipoint systems such as IEEE 801.11h. The IoT World Forum standardized architecture. So it offers a clean, simplified perspective on IoT, and it includes edge computing, data storage, and access. It provides a succinct way of visualizing IoT from a technical perspective. So each of the seven layers is broken down into specific functions and security, which encompasses the entire model. Here we can see the IoT reference model published by IoT World Forum. We have like the edge computing, the collaboration in the processes, applications, data abstractions, data accumulation, edge computing, connectivity, and physical devices and controllers. So this is the one where the layers that is been interacting with one layer and other layer. So physical device, the first one. The second will be the connectivity. The third will be the edge computing. The fourth will be the data accumulation. The fifth will be the data abstraction, then application, and then the collaboration and the process, which involves people and the business process. So here the IoT reference model defines set of levels with control flowing from center to the edge, which includes sensors, devices, machines, and other types of intelligent and nodes. In general, Data travels up the stack, originating from the edge and goes northbound to the center. Using these reference model, we were able to achieve the following: to decompose the IoT problem into smaller parts, to identify the different technologies at each layer and how they relate to one another, and it defines a system in which different parts can be provided by different vendors. It has a process of defining interfaces that leads to interoperability and define a tiered security model that is enforced to transition points between levels. So we have the layer 1, we have the layer 2 connectivity layer. So we have the functions of the connectivity layer, and we have the edge computing layer, and which has the stress functions, and the upper layer, that is 4 7 layers: data accumulation, data extraction, and collaboration, and the process layer. So we have like reference model separation of IT and OT. So it is very interesting. It is queue based, and additional IoT reference model, the Purdue model for control hierarchy, Industrial Internet Architecture by Industrial Internet Consortium, Internet of Things Architecture. So these are the keywords that we have seen today. In summary, the IoT systems have to cross several boundaries beyond just the functional layers. The bottom of the stack is generally is the domain of OT. So for an industry like oil and gas, this includes sensors and devices connected to pipelines, oil rigs, refinery machinery, and so on. So the top of the stack is in the IT area and includes things like the servers, databases, applications, all which runs on a part of a network. So we have multiple choice questions, so we can go through it.